Welcome to the training video about the Leanheat Network Demo Model. A few words on the purpose of this training video. The instructor will do a walkthrough of the Leanheat Network Demo Model. The model file will be installed with Leanheat Network. This will give you a chance to watch how to configure and, moreover, how to discover and analyze district heating network challenges in various ways. It is important to understand that the demo model is not a real network model. It is a model based on street lines and building locations in an area somewhere in Denmark. And now over to the instructor.
Once installed and launched, the Leanheat Network model opens in the standard dashboard. This dashboard is set up to show some of the most important controls, such as themes, views, profiles, time series, legends, and of course the main element, the district heating model. The model design consists of nodes and the pipe network and consumers. Let us just turn on the consumer layer. The design, moreover, includes two heat production locations. In Leanheat Network, these are called plants, Plant West and Plant North. There is also a pump and a valve. Every consumer must have the following setup, and let us just open a consumer object in the generic editor. The consumer must have values for a nominal power, a temperature return, and a consumer type. In our case, we only have one simple consumer type, here number 1. It is defined with a profile by the name TS_1 that is added to all consumers. It is a daily profile that enables us to run a dynamic simulation for one day in an easy manner. The timeline indicates that results are loaded into the model. Let us take a look at the results by first opening the time series named Plant Power, where you see the results of the heat production in the two plants. What you see here is the two plants with varying power. Notice how Plant West has a somewhat funny shape over the day on an hourly basis. If there is more than one plant in the network, which is the case with the demo model, then you are required to define the criteria for the heat production depending on the actual load. In our case, we use the embedded tool, the production plan. This tool enables us to set up our production units based on priorities. Let's have a quick look at that tool. From the menu bar, select Model Handling, and then Production Plan, and where I select Standard. The top priority is the cheapest solar production. The next priority is the combined heated power. Both are in Plant West. Plant North has gas and oil with a lower priority. Then it is necessary to define the production capacity, minimum and maximum. And additionally, also configure the prices and uptime of each individual unit. The results on the next tab are based on the current setup. For the solar, we also have a time series defining maximum production over daily hours. In the last step, we already have results for the current simulation. Let's have a look at our production consumption in a somewhat different way. Here we are now looking at the total production in our network total heat loss, which is the red line and then the curves from our two production locations. And below we have the heat loss from the entire network. For every time series and profile, you can look at the data in tabular form. This makes it an easy task to copy the data and paste it into, for example, an Excel spreadsheet. As we have more than one plant, we can display distribution zones for each individual plant with a map rendering theme. I will switch to the theme Plant North Concentration. Stepping through time starting from midnight by using the slideshow feature, we can observe the moving of the boundary for supply zones and also how the direction of the flow can change as indicated by the arrows on the pipes. The switching of direction may indicate possible stagnation zones where the water potentially has a long transfer time with decreasing supply temperatures. Let us have a look at another theme. Here we see a map renderer with a pressure difference in the network, and on the pipes showing the pipe velocity as it also appears from the legend. Notice the varying differential pressure zones depending on the demand in the network, and watch where you find the constantly highest differential pressure here in the northwest region where the pump is located. You can also see areas with constant low velocities, which is a value below 0.1 meter per second. You see these overlaps with stagnation zones as seen earlier. But we also have some in other areas. To view these, right-click the color in the legend and then point to select objects and view the potentially affected areas. The display is of course time-dependent, and here we see the morning hours are the most represented. Looking at yet another theme, this time it is called velocity and supply too high. Here you can observe the designer typical configuration and notice changes. Wherever there is a red line, it is an indication of exceeding the limits of individual pipe dimensions. So in this model, there is only a problem in this area near Plant North. These pipes are bottlenecks with clear indication of a high velocity. The pipes should be subject to a redimensioning when you have a chance for maintenance, or maybe enforce the supply by rerouting the flow. Let us have a closer look at these pipes that constitute bottlenecks. I zoom to open the pipe for editing. Right-click the pipe and point to the object for detailed editing in the generic editor. Under the Data tab, we can see the dimension is 150 under pipe type, and under Results, we are interested in the values for velocity and the pressure gradient. Right-click the property values one at a time and watch as a time series and how the profile matches the consumer profile and that the pressure gradient and velocity are really high and exceeding the limits. These are clear targets for dimensioning. So far, we have only been looking at the model from a theme perspective and showing results. There is, however, another possibility of how we can inspect our model. This is by looking at profiles. The profile can be a good tool when trying to get an understanding of pressure variation and effect of pumps and valves. Let us have a look at Head Profile North. In the profile, you see a chainage. Let us have a look at where it is located in the model. Right-click the profile and select the menu item Show Path. You will now see a highlighted route from Plant West to a point in the north across our pump and valve. Based on the head diagram, it shows the reason why the pump is introduced, where it is to overcome the elevation range and minimum pressure difference. You will see how we are avoiding cavitation in this area and reaching the maximum head for our supply, which tells us the model is within boundaries. If any of the pressures would go below the elevation point, this is where we will risk the cavitation. But if the pressure goes above the maximum head, then there is a risk of overpressure in pipes. As a final demonstration element, there is another type of profile, a critical differential pressure profile, which is based on a critical path. How does that work? Well, in the critical differential pressure profile, right-click and run through the time for the profile. You will notice that the path can actually change its location, as you see here. This was a short introduction to the demo model that comes with the Leanheat network installation, and that you can use as inspiration and to investigate how certain features or functions are configured.